All right. So hello guys and girls. This is the first part of the lecture for week 1. So first of all, let me explain my way of doing the lecture. The way I do the lecture for this course is that I put the slides on and I read through the lines, each one, one by one, and I explain the concept, explain what that means. I show you more examples if you need, if that needs, and I just go to the next slide. So I just use those slides as the base of the course. And the other thing is, you have one assignment this week, so please stay. I will explain that later. That would be a short assignment, very, very short, and I will tell you what to do later. So first of all, let's do the lecture. So chapter 1, Introduction to Modeling and Problem Solving. Let me explain what this course is all about. So it's all about making decisions in real life and in business. We can use computer to analyze the potential outcomes of decision alternatives. So that's the role in here. We want to use computers. We want to use methods and computers to do the analysis and find the potential outcomes for decision alternatives. Sorry about that. So spreadsheets are the tools of choice for today's managers. Something that they use a lot, spreadsheets. And it basically means softwares like Excel and Google Slides, Google Sheets. A field of study that uses computers, statistics, mathematics, and these kind of things, these kind of tools to solve business problems, known as operations research, management science, and decision science. So these are all the same. Sometimes they use decision science. Sometimes they say management science. As you know, the course is management science. So these are 5 steps of decision-making process. So when you want to do this, make a decision, we have to go through this path. First, identify the problems. So identify the problems. Understanding the case, understanding the problem, that would be the most important part and the first part of the decision making. Then after that, identifying alternatives. So how many choices we have in this situation? So first of all, what the problem is, right? Tells us a lot. And then identify alternatives, the choices, what we can do about it, right? What's the first choice? What's the second choice? Do you have all the choices, all the possible choices? Is there any other choice that you can consider? The third one is determine the criteria. Okay, so what's going to happen if you pick this one? What's the restrictions? What are the restrictions? What are the criterias? Okay, so criterias of the problem. The next one is evaluate alternatives. So now that you know all the things, then you know what happens if you pick this one and what are the restrictions and everything else. So now you should be able to evaluate every single one of your options or alternatives. And then based on some result that you have, you should be able to conclude which one of those are the best one. So choose one best alternatives. So define the problem, identify alternatives, determine the criteria, and then in the right part, so all of those are the structuring the problem, The right part is analyzing the problem. So now analyzing the problem means you have two choices. You have two ways, let's say. You have two ways to analyze a problem. And that part is the last step. So we can, when you want to evaluate those options, you can do it like qualitatively or quantitatively. So quantitative analysis or qualitative analysis, and summarizing and evaluating and then making the decision. So these are different, qualitative and quantitative. These are different approaches. So let's talk about those. Quantitative versus qualitative analysis. Quantity versus quality. So we use the term quantity or quantitative approach when we're dealing with numbers. If you can just explain something in numbers, that would be quantitative. So quantitative analysis means, or approach, is the approach that you consider numbers. You can summarize everything into numbers and just result based on that mathematical analysis. Okay, find the best solution, find the best alternative based on that, based on those numbers, raw numbers, right? And the other one, which is quantitative, is the one that you conclude based on your experience. So you sometimes you can say, okay, I know this happens if you go there. I know. How you know? By your experience. So this is something we call quantitative approach. So that would be qualitative approach. So that would be qualitative analysis. So this approach, the second one, although it's not something that you can put in numbers, but still we can do something about it. We can do some analysis. We can use it, let's say, using some management methods, some management science method. We can go and use this approach as well. So as you see, those skills in quantitative approach are inherent in the manager and usually increase experience. Usually increase with experience. The quantitative skills can be learned by studying the assumptions and methods of management science. So we still can learn this using management science and improve ourselves in that matter, in that approach as well. So, but that's not something we focus on. The focus of this course is the first option, quantitative, because we're going to deal with numbers. So, due to the following reasons, quantitative approach has priority over the quantitative. And these are the reasons. So the first one is a better one. We just claim for these reasons. So first of all, the problem is, so these are the cases that we picked the first option for the solution. So sometimes that the problems are complex and managers cannot develop a good solution. We pick the first option, quantitative approach. Sometimes problem is really critical, like we deal with numbers, we deal with a lot of money. That's very critical. We can't just rely on quantity or quantitative or the opinions of these managers. We have to have some concrete reasoning in here, concrete evidences, something that we can rely on. The problem is new, and managers, they don't have any experience. Sometimes the problem is new, never happened before. So that's another situation. The problem is always we have always that problem again and again. It's coming. Like always, we have this every month. We have this problem every week, or just we have that every day. So sometimes it's not something. It sounds like it's not going away. So in our case, the problem is repetitive. Quantitative analysis is based on using methods. Okay, let's get back. And so it's based on what? It's based on modeling approach. That means we need to learn how to model problems. So types of models. We have 4 types of models. First of all, we have mental modeling, and mental modeling means just having something in your head, thinking about something. Just for example, think about your furniture. What happens if you put the sofa over there? What's going to look like? What's your like dream this situation? What's your dream home? How's it look like? This is something that it's mental. It's mentally. You don't have it on map. You don't have it in computer. You don't have any physical model of that. You're thinking about that situation. So that would be mental. Visual is something that you can see. It's a model that you can see, something which is, but it's not a 3D. So it's kind of like a 2D blueprint, roadmap, something that is visual but still not physical, because physical, the next one, which is slash scale, it's a 3D model. So that would be a 3D model, like a small model of a house. And the 4th one is mathematical. And that would be something we're going to deal with. So mathematical is the one that we're going to focus on in this course. So what's a computer model? A set of mathematical relationships and logical assumptions. When we implement them in a computer as an abstract representation, of real words. So something like a mathematical model with restrictions and relationships and everything that we know about that situation in a math kind of language. If we can just put those in equations and variables and just have them in a computer, like in a program, that would be an abstract representation of a real world that explains the object or situation. So we call that a computer model. Spreadsheets provide the most convenient way for business people to build computer model. So it's not a surprise, because we can deal with equations, variables, and those kind of things in a spreadsheets. Pretty good. That would be easy to use the spreadsheets for these kind of situations, because you don't need to program mostly. It's kind of like ready to use. Models are usually simplified version of the things that they represent. So what's the meaning of that? Models, they don't explain that the object fully, right? They just represent and just 1, 2, or 3 aspects of that object. They simplify. They are a simplified version of that thing. A valid model represents the relationship, or let's say represents the characteristics of that object that matters to us. Let's say the valid model accurately represents the relevant characteristics of that object that's relevant to the situation, relevant to the problem, not everything, just something that we need. So let me give you one example of this situation. Like what? Give me one example. Like a circle that you see on a map. When you have a map of one area with just like local cities on that map and roads and rivers and everything else. So when you have a circle that says here's Vancouver, that little circle doesn't represent, it's doesn't explain everything about Vancouver, right? It just represents Vancouver, and it just has some relevant characteristics of that city. Like what? It just tells us about maybe the situation of the the situation or the like location, lat and long, or like x and y of the city, or it just represents the relationship or just like um, relative location of that city regarding to other cities or regarding to like other features on the map. So it doesn't have everything. It's a simplified version. It just tells us something that we need to know. Benefits of modeling. So they're cheaper, right? So they just because we can simplify them. So in terms of like cost, they're cheaper, less costly. So we can make we can just do our analysis faster because like I said, we just show whatever we need to know, not everything. So sometimes if you use a right types of modeling, it would be a lot cheaper and a lot faster. Feasibility. This is about like situations that are not possible. Like sometimes it's not possible to just analyze the situation using realities. Like what happens if you go to that dangerous area? So we don't do that. We don't test it to just experience that. If you just walk something in some area that is not really safe for people, it's kind of like impossible situation. So for that reason, we're not going to do that thing. What we're going to do is we use a computer model. We simulate the situation. We just use something which is not you. Sometimes we can use like robots. Okay, so that little robot is a human model. It could be a human model, represents the people, not everything about people. It doesn't show every characteristic of a people or person like you, but it has everything that we care about. So maybe dimension, maybe some other features. So this explains the feasibility. We can work them. We can analyze things that's not possible in real world. So, or sometimes even if they're not possible at all, but we can analyze them if you use modeling. So they're cheaper, they're faster, and feasibility, which explains sometimes we can considering modeling, we can do things that are not possible. So one example of this situation is example of mathematical models. Well, one good example of mathematical models, cost, revenue, profit analysis. So this is the same thing, the same problem that we have done in business math. If you remember, and I think you've already passed the business math. So this is exactly the same thing. Profit is equal to revenue minus cost. So that's the relationship between these concepts. We have some revenue, we have some cost, and if you just subtract them, I mean, consider revenue minus cost, that would be profit. So X here, if you just focus on this part in here, if you want to find out the revenue, you have to do this math, selling price times the volume. And if we consider volume, if you just put X for volume, X is a model. X is going to be a model of volume. So what this X has that represents the volume, it just can tell us about numbers. So it has what we care, not everything that volume does, right? So cost is fixed cost plus variable cost per item, which is variable cost, times volume. So if you consider that X, it just becomes this. So consider a firm with a linear cost function C as a function of X, revenue function R as a function of X, and profit function P given by. So if you consider like these, cost function going to be C times X plus F. And revenue going to be set, and C, by the way, here would be C, by the way, here, right, is unit cost of the production. So that would be a variable cost. This is a selling price, and this is a fixed cost. And if you consider those, that these are relationship between, these are the relationship, right? All the cost, revenue, and the profit going to be revenue minus total cost. And if you do the math, it's going to be selling price minus cost per item times X minus F. So this is something that we have done in business math, not new. And for break-even point, if you remember, we need to just put the profit equals 0. So break-even point is the point that we don't have any, we're not going to gain any money, and we're not losing any money at that point. So we need to put these two equal to each other. So all the revenue going to be all the cost for one specific volume. And that would be the level of production. So at the level of production X naught, the profit is 0. That's the meaning of break-even point. We call that break-even point. So this is the break-even point. That would be P naught is the break-even point, and has two variables. So X naught and Y naught. These are two numbers, right? The first one represents the level of production, and the second one, which is X naught, represents both of revenue and cost, because those are the same. So those are going to be the same. Here, so if you put everything on a map like this one, like what you see in here, this pink line is cost function, and the blue line would be revenue function. So by function, I mean, these are the function, they're like a function of X, right? So if you change the X, they're gonna change. If you put a different X for like profit, for revenue gonna be different. A different X for cost, the cost is gonna be different. So if you put those two lines, those are two lines. If you draw them, right? If you just map these two lines, they're gonna cross each other at some special point, and that point is, guess what? Is the break-even point, right? This is the break-even point. So here is the profit area, here's the loss area. So that means what? If we produce less than this special X, so here is the X and here's Y. So if you produce less than X naught, you're gonna lose money. More than this, you're gonna gain a little bit money. So how much you gain is simply you need to just find out this area, right? Revenue minus cost. So this much you gain. If you produce more, this gap going to be a little bit bigger. So bigger gap, bigger area, right? Bigger distance, let's say, more money. And here we're going to have the opposite side, opposite the same thing. We lose money if we have a bigger gap. So, so here you go. This is the all the things that we know about break-even point. So profit, revenue minus cost. And if you just put them less than 0, that would be the area that we lose money, loss area, right? If you consider that greater than 0, like here, this is the area that we gain money. So profitable level. So here is one example. And now I want you to look at this. I want to pause for just 1 minute. And I want you to pause, read the question carefully, and try to do this analysis to find the equations and find out the relationship in mathematical terms. So I'll pause it here to take a look, and I see you in the next part. So that would be part 2.